Now we need to turn our attention to executing the code. And to execute the code, we need a little bit more information that I glossed over in that first pass. There's some meta information that gets discovered as we go along that is not entirely obvious as we go. And I skipped over it, but let's go back and fill in that meta information. There's something very important about where a variable shows up. Because where it shows up, the context in which it is used, determines how it's going to behave at runtime. Remember I said earlier that an identifier can only be in one of two positions. Either it's in a position where we're going to, in some way, shape, or form, extract the value from the variable, or it's going to be in the position where we're going to put some value into the variable. It's really the only two options. Okay? And there's a special term for that. But the reason that's important is that we're going to treat that differently at runtime. There'll be different validations on stuff depending on which position it's in. So that information was stored as the compiler was going through. In essence, it kind of knew, or it's stored based upon some meta information. It knows, for example, that the foo on line 4 is on the left-hand side of the equals, as opposed to being on the right-hand side of the equals. It knows what position it's in. And the position matters. If something is on the left-hand side of an equals, it's going to be the target of an assignment. If it's on the right-hand side of an equals, it's going to be the source of an assignment. It's going to be the source value. Okay? So in essence, we have this question of, is it in the left position or the right position? That's basically when a compiler theorist talks about it, one of the things they ask is, what position is it in? There's different terms for this. I'm old school because I took computer science a long, long time ago. My professor called it LHS and RHS. LHS stands for left-hand side. RHS stands for?
Right-hand side.
Yeah, come on. Right-hand side, right? Pretty easy. Left-hand side meaning it's the target of an assignment. Right-hand side meaning it's the source. Not always the source of an assignment, but definitely the source. Okay? So it might be more helpful to think of target source versus left, right, LHS, RHS. It's just my habit to call it LHS, RHS because that's what I learned way back in the day. Okay? Some more modern terminology, they'll use L value and R value or some other kind of, whatever the terms are. You understand it's either the target or it's the source. Okay? That's metadata that we need to store with that variable because we're going to treat it differently depending on whether it's a target or a source. So that metadata is stored with the variable. Now, it's time to execute this code. And now that we're executing, there are no more var declarations, and there are no more function declarations. We handled that at compile time. Declarations are not a runtime thing. We don't need to worry about them. All that's left is the executable code, and technically, it's not even in source code form anymore that we could read. We're going to pretend that it's still written like this, even though it's not actually. Okay? So just pretend that the vars are all gone and the function headers are all gone, and all that's left is the executable code. That's why I said earlier in our course, when we said var bar twice, the second one was a no-op because the compiler came across that var bar and he said, have you ever heard of the bar? And it's like, yep, got him. Then it's a no-op. I don't need to put another duplicate marble in the bucket. It's a no-op. So by the time we run the code, the var bar doesn't exist anymore because it's already been handled. Okay? So now we want to execute this code, and we're going to have two participants in this conversation. Now it's going to be the JavaScript virtual machine. The engine is going to be doing the running, the executing of the code. But to do his work, he needs to have access to the scope. So he needs to still talk to the scope manager. Okay? Now, as I go through this conversation, I have been feeding you the terms here, but I'm going to expect for you to participate more in this, even though it sounds silly. I want you to actually participate in this part of the conversation. So we're going to say, I'm the JavaScript engine now. We're looking at line 1. There's no var there. But I do find a foo, and I find a foo in that target position. I find a foo in the LHS, the target position. And I need to figure out whether or not that variable exists. Because it might be that I'm using a variable that hasn't ever been declared, and that's an important detail. So I'm going to need to have that same kind of back and forth conversation with the scope manager that compiler had. That conversation is going to go like this. Hey, Global Scope, I've got an LHS reference for a variable called foo. Ever heard of him? It's, again, one of those yes-no questions. But there's even more nuance here. How many of you have ever played or seen the game Go Fish, the card game Go Fish? Anybody ever heard of that? Okay. So I got young kids. I got a 4-year-old and a 6-year-old at home, and I love playing Go Fish. My son, he's 6. I love playing Go Fish with him. He's almost at the point where he can hold his own cards, but he still kind of has to like set them down and like arrange them and stuff, and I have to like pretend that I'm not looking at his cards. I'm like, hey, you got any 8s? But what I love about the Go Fish game is it's just such a simple premise. I ask a question, do you have a foo variable? And there's only 2 answers, either yes, here you go, or what?
Go fish.
Go fish. Go look elsewhere. In the game of Go Fish, I got to go to the deck to see if I can pull out the card I'm looking for. Here, the same premise applies. I am the engine, and I am looking for the marble. I have a reference to this marble, but I need it. And it's the scope manager's job to go tell me which bucket it's in and hand it to me if it exists. So I'm saying, hey, scope manager, hey, global scope, I have this target value, this L value, this LHS foo. Ever heard of him? And if he has, he's got to go get me the marble. And if not, he's got to tell me, nope, sorry, look elsewhere. What's the answer going to be this time?
Yes.
Yes, I have, because at compile time, we added a foo variable to that scope. We added the red marble in, right? So the global scope manager is going to go get that red marble and hand it back to me. And now I have a variable. I have a location in memory. I can go to the right-hand side, find that value, which is the quote bar, and I can make the assignment. Do you follow how that happened? It only happened because there was a formal declaration for me to discover. Had I been trying to do that and the answer had been no, a different end result would have occurred. Okay? We'll get to that in a moment. Now, we don't see any other part of this program executing the bar or the BAS function. That's on purpose because I didn't want to make things more complex. We don't see bar and BAS being executed. So let's just pretend that some other part of this process executes them. Maybe they get executed as a click handler or on a timer or just in some other part of the program. Somebody calls the bar function. So let's execute the contents of bar, and we're going to do it exactly the same as we did before. We're going to start with this line 4. And on line 4, there is no var there. There's just a foo equals. So how's that conversation going to start? Which scope are we talking to? Hey, scope of bar. I have a what kind of reference?
Well, there is a var though. What do you mean there's no?
It's already been compiled away. We're executing that, right? There's no var. It's been compiled away. Hey, scope of bar. I have a what kind of reference?
Left-hand reference.
I have an LHS reference, an L value, a target, whatever you want to call it, for foo. Ever heard of him? And the answer is?
Yes.
Yes.
Yes, because you declared him formally during the compilation step in this scope. Here's your marble. So now we have the marble. We go to the right-hand side of line 4. We find quote BAS. That's an immediate value. We make the assignment. Line 4 is complete. Have I lost anybody yet? Make sense? All right. Now, sometime in the future, somebody decides to execute the BAS function. For now, we're going to assume that they don't pass in any argument, because there is a parameter that could receive an argument. Let's ignore the argument passing for now. Let's just assume they invoke the BAS function. Okay? We need to start executing with line 8. Line 8, how's it going to execute? What scope are we talking to?
Does.
Hey, scope of BAS. I have a what kind of reference for foo?
Left.
I have an LHS, an L value, a target reference for foo. Ever heard of him? The answer is?
Yes.
Why? Because of that foo parameter on line 7, right? On line 7, you formally declared it, so for all intents and purposes, that's a variable that we have access to. We can assign to, okay? Great. So now I have my green marble. I've got my marble, and I go to the right-hand side, I find quote BAM. I assign quote BAM into that variable, and we're done with line 8. We good so far? Now we finally come back to line 9, which we skipped over essentially during the compilation. We didn't do anything with the scope of it. We did keep track of the fact that it was in an L value position, but we didn't do anything scope-wise with it. And now we need to ask, what's it going to do at runtime? So that conversation needs to proceed exactly the same as before. So how does it go? Hey, scope of
Does.
BAS, I have a LHS for
Bam.
BAM. Ever heard of him? And the answer is?
Go fish.
Go fish. Right? Because there is no BAM declared in that scope. So now we need to understand, what does go fish mean in terms of lexical scope? Lexical scopes are nested. So the default behavior then would be to say, I'm going to go up one level of scope and ask the question again. In this case, that up one level is the global scope. So we're going to go up to the global scope and say, hey, global scope, I have a LHS for BAM. Ever heard of him? And the answer is?
Go fish.
No.
Okay, so we would like for the answer to be no or go fish. There's nowhere else to go because the global scope is the end, right? That's the deck. It's either there or it's not. Doesn't exist. It would be nice if it said no or through an error or any of those things. But unfortunately, we have a historical decision made early in JavaScript to be more friendly and forgiving, I suppose. What the global scope will actually say is, well, no, but I went ahead and created one for you anyway. Aren't I helpful? What? It just implicitly created a global at runtime because it couldn't find one formally declared. So now we have a global variable called BAM. We have a red marble called BAM that we get handed back. And when we make the assignment on line 9, we are assigning to a global variable called BAM. You see that? Now, that process that I just described, where we implicitly create a global as a result of assigning to a variable that was never formally declared, that is virtually always a mistake. Let me say it this way. If you're doing that on purpose, stop doing that. That is never the right way to do it. Never, ever, ever should you code assuming that you will implicitly create a declaration in some global scope. That is a terrible idea. Yes?
So is the process the same if it's LHS?
We are talking about LHSs. Are you saying if it's the same?
RHS.
We're going to get to RHS in a little
Okay.
bit. Hold on to that question. Okay? Right now we're talking about LHSs, and this undeclared LHS, or unfulfilled LHS as I like to call it, results in an implicit auto global. And that is a terrible, terrible thing. Okay? Terrible for confusion. You end up accidentally creating and overriding variables that you never intended to do. Since it's almost always an error, it turns out if we use strict mode, it is actually an error now. So all that same process that I went through in the previous slide, if I did it with strict mode on, which is what I'm doing up here, I've turned strict mode on for the program, or I could have done it at the function level. In either case, when we got to that line 11 now, when we said, hey, global scope, I have this LHS for BAM, ever heard of it? The global scope would be prevented from creating that variable because of the strict mode, and its only other option then would be to throw an error, because it can't create one implicitly. It would have to throw an error, and specifically the error that it would throw is called a reference error. Reference error, BAM is not defined. That's literally what it would say. That does not mean the same thing as reference error, BAM is undefined. Remember, earlier in our course, we talked about the difference between undefined and undeclared. BAM is an undeclared variable that we just start trying to assign to. It is not an undefined variable. An undefined variable would be one that was existent, that did get declared, but at the moment had no value. That's undefined. I really wish that error message said reference error, BAM was not declared, because that's a much more accurate statement. I've been asking them to fix that error message for about 5 years, and they have yet to fix it.